Welcome, everyone, and thank you for joining us to learn more about the latest AI technologies from Nvidia and IBM, and more importantly, how these technologies can help you streamline your AI workflow and speed up your journey to the operationalization of AI. I'd like to thank our two speakers, Dan Squara and Douglas O'Flaherty, for their time today. Nvidia has pioneered accelerated computing, a supercharged form of computing. And today, accelerated computing is reshaping trillion-dollar industries like finance, government, healthcare, and manufacturing. I like to refer to this accelerated computing as the beast. IBM Storage for data in AI enables customers to seamlessly introduce AI initiatives in a hybrid cloud environment. And IBM Spectrum Storage delivers enterprise-ready storage that is secure, scalable, fast, and is all about feeding the beast. You likely imagine Nvidia and IBM as hardware companies, but don't be fooled. These companies are winning in the AI space because of their investments in the enterprise-ready software that will accelerate your AI workflow. So our moderator today is going to be Kim Boisson-Shin from R2I. If you have any questions, please type them in the Q&A section. And at the end of the conference, raise your hand and you'll be unmuted. Please, truly, I encourage you to ask questions. So my name is Tamara Vandersloot. I'm VP of Innovation at R2I. I spent 29 years at IBM and doing technical pre-sales, and 7 years ago left IBM to be one of the founding members of R2I, a company based in Quebec and offices both in Toronto and Ottawa. We're now over 40 people and growing quickly. I've had the privilege of doing several service mandates around AI, such as building AI roadmaps, running use case workshops, and having the opportunity to interview institutions around the world concerning their lessons learned and pain points in the operationalization of AI. Dan Squara will be speaking today. He's a senior solution architect from Nvidia. Dan is an industry veteran with almost 20 years of GPU and accelerated computing experience. After more than a decade of scientific visualization and data processing for some of the world's most renowned astrophysics and cosmological institutes, he has returned to Earth to focus on the virtualization world. Dan is VMware, vExpert, and combines his passion of GPU computing and enterprise infrastructure to help AI in the modern data center. Douglas O'Flaherty leads new technology adoption with IBM Storage with partners like Nvidia and Cloudera. He's been working on the leading edge of technology adoption since the early days of the internet and the emergence of new business models. He shifted to high-performance computing at AMD in 2003, leading the adoption of AMD across multiple compute-intensive industries such as oil, gas, weather modeling, and financial services. In 2005, he started working with Nvidia CUDA and quickly recognized that the fast computing needed better storage. He went to a storage startup when it was acquired founded by the founder of Fusion.io. And after a short period with a cloud startup, he's been recruited by IBM Storage and is back to working with accelerated computing systems. The agenda today, I'll do a quick overview of who R2I is and talk about some of the common pain points that I learned about on my interviews. Then Nvidia will speak, IBM, and we'll talk about the next steps, and then we open up for questions. Who is R2I? The R stands for resources. We're really about a large team of technical resources available for our customers. The two I's, the first one stands for infrastructure. We offer infrastructure, whether that be on-prem, in the cloud, or in a hybrid. And integration is all about integrating your business into these new infrastructures. So R2I is an infrastructure partner for artificial intelligence solutions. We architect the infrastructure that meets your needs among the various vendor options available for you. We can do the services from the managed services for taking care of all of the service for you. We can do rack, stack, install, configure, and as I mentioned before, we can do services around doing AI use case workshops, building the AI roadmap for your company, or creating your AI lab. And we do on-premise solutions. We go from services, networking, storage, OS, and tools. It's really a full from A to Z. So quickly on some of the pain points that I've learned about, which is really kind of why we started this presentation and is really about the two major pain points fall in the category that I've seen, which is the training times. And that's largely driven by the number and the size of the data sets that are increasing exponentially. The AI models themselves are growing because as they get more accurate, they often get larger in size. And it's about keeping those GPUs, which is the biggest part of your investment in your infrastructure or in the cloud, at high utilization rates. The data pipeline is traditionally where you're going to spend 80% of your time on any kind of AI project. And that's really the pain points that I've seen is really about finding the data, because it's largely siloed all over the companies. It's about having the data in the high quality data that's labeled and ready for ingestion by AI, and the ability to move that data fast. So it's really about feeding the beast. So now I'll pass it on for Dan, who's going to talk about NVIDIA's solutions. Over to you, Dan.
Thank you very much. I'm going to grab presenter here and share a couple slides with everybody. So what I'm going to talk about today is modernizing your AI transformation within your own organization. Can everybody see this? Look good, Tamara?
Yeah, I can see it.
All right, great. Let's get started. So my agenda for today, I'm going to talk about three quick things. The first, I always like to start with the evolution of AI. Where did we come from and how did we get here? Second, I'm going to talk about how NVIDIA is leading that AI revolution, what we're bringing to market, the advancements we're making in the data center, in accelerated computing, give you a broad scope of what we're up to. And then lastly, talk about how AI has actually been transforming modern businesses, modern governments, modern processes. Just about every facet of your life is going to be touched by AI. So we'll touch on a couple of those examples near the end, so you get a better understanding of where this technology is used and how you can utilize it too. So let's start at the beginning, and we're going to go way back to the beginning, the evolution, where we started with AI workloads. And it all started back in roughly 2012. I like to bring this up because prior to 2012, we already knew what artificial intelligence was. We had machine learning, we had ideas of what deep learning could be, but there were no computers in the world fast enough to make this a reality. So the frameworks existed, just the technology wasn't there. But 2012 was revolutionary. There was a yearly competition called the ImageNet classification competition. And in this, a young college kid named Alex Krasinski was one of the first persons to ever take these artificial intelligence frameworks, these mathematical concepts, and accelerate it on a GPU. It was revolutionary. It started this entire explosion of AI in the real application worlds. Alex won that competition hands down. He was orders of magnitude, maybe 10 points even higher in accuracy than the most advanced CPU-based system. And once that started, it created a shockwave through the entire industry. It kind of created this expanding universe, if you will. That big bang starts on the left there. As Tamara mentioned, I'm a space guy. I love this stuff. So you're going to notice a lot of space references here. But that big bang, that inception in 2012 started. And from that point forward, AI was being adopted across research, across core technologies and frameworks becoming developed. We're moving into the eras now where tech startups are entirely based on AI, and just about every major industry, all of those leaders are currently using this technology. They are putting it into production, and that's what we want to help you with as well. We want you to be part of this expanding universe. Now, AI is kind of a broad term. What do we actually mean? Give me some examples of where we see this technology already. And here's a couple that are close to home. Things like your cell phone. Did you know that 20% of all searches now are done via voice? And that voice, when you talk to Siri or Alexa or whoever it may be, is actually AI. Those deep neural networks were created to do natural language processing, so that way we can understand the data coming in, the request, formulate a proper search result, and then talk back to you in a natural language. Of course, the ones that you're probably very familiar with are the recommendation systems. AI finding patterns in human behavior. Netflix will tell you what you should watch next, or your favorite shopping website knows your spending habits based on similar data from elsewhere. But it's not just close to home. We have these type of examples everywhere, and it's a broad example. So, for example, we have our basic internet services, those image classification, the automatic tagging of faces when you upload a picture in Facebook. New advances in medicine, using this type of accelerated computing to analyze radiology scans and make decisions quicker. Things like security and defense. I always like to say cybersecurity is a data problem. There's too much data too quickly for humans to understand it. Luckily, AI can help us there. That's exactly what it's designed for. And then some of the more fun things like our self-driving cars and self-driving trucks coming up, automatic lane detection warnings, the ability to have smart cities and smart traffic lights. Look, AI is going to be everywhere. And these are just a few examples that we're going to talk about. But that's where we started back in 2012 with that huge explosion of AI interest, and now it's broadly adopted everywhere. So how is Nvidia facilitating this? What are we doing to bring this to market? Let's talk about what we are, where we started, and how Nvidia is helping. Nvidia does three things better than just about everybody else. We started in graphics. Of course, this is our bread and butter. We've been known for our high-powered and fantastic graphics for years. RTX is the newest iteration with that real-time ray tracing, and it's no different. Absolutely foundational in Nvidia's history. Now, beyond that, we moved into HPC next, and we realized that using those same GPUs, the same graphics accelerators, we could create highly accelerated workflows in the HPC space. So we did. We started putting these accelerators into the data center. We evolved into supercomputing. And from there, we made the next logical jump into AI. Using those accelerated libraries, all of the components, software, expertise that we had in this massively parallel computing, both in graphics and HPC, and use that to train AI frameworks, to build infrastructure that can support AI workloads for just about all industries. So that's where we came from, and this is where we are today. We are now the AI company. Now, there are two main challenges that I want to talk about with AI computing. And the first is the computational requirements necessary and why GPUs are the ideal way to do this type of calculations. So as I mentioned in the very beginning, there were no computers fast enough to run these AI algorithms back in 2012. And the GPU was the first system that could legitimately do this in someone's lifetime. Now, comparing CPU performance, that was the tradition, and GPU performance, I have this handy graph here that's kind of showed us the advent of where single-threaded performance has gone, and where it's come from, where it's going, and how GPU performance has been, surpassing it orders of magnitude. And the reason for this is because we're wildly parallel accelerated. Things like our CUDA architecture help us do that. And while CPU performance, we add a couple more cores every year, with GPUs, we add tens of thousands of cores every year. We are constantly accelerating, and we just think this gap is going to get larger and larger. So for that reason, the GPU becomes the more ideal place to do these massively parallel computations. Now, the second important part and the more difficult challenge to solve is the data size. I alluded to this before when I said that cybersecurity is a data problem. Well, it's not just cybersecurity. This is everywhere. This is COVID-19 analysis. This is exabytes of data being created, or terabytes per second from radio telescopes, or geospatial information, or just YouTube videos being uploaded. There is a massive quantity of data being created all the time. And also, not only the data creation, but the models, the AI models that we use get larger and larger as we add more complexity to it. Take natural language processing. It's pretty simple to understand a word and a meaning. That's a dictionary lookup. But to understand a sentence, that's additional complexities. Then to identify a person speaking within multiple groups of people and identify their sentence, that's more complexity. These models keep getting larger and larger and larger, and that's not going to stop anytime soon. As a quick example, I wanted to just highlight some of the data that's coming in and where we've come from. Douglas is going to do a great presentation on the data. This is just my quick take on it as well, so I don't want to steal his thunder. But we started in the business process world. We started with some basic file services needed. And then we entered the web era, where we started having things like search engines and web logs and a little bit more. As we grew and digital content was king, things like social networks and HD video, the explosion of data was immense. And finally, in the new AI era, where we are today, things like automated sensors, smart cameras, smart cities, IoT data, there's just too much to come in. There's too much to process. And luckily, AI is there to handle that huge amount of data coming in, Douglas, again, will do a great presentation on how we can tackle a lot of this data coming in. But just keep in mind, these are the two biggest constraints we have: the computational power necessary, and of course, the data side. So let me talk about the computational power and what NVIDIA is helping with. And first and foremost, our latest GPU announcement, the NVIDIA A100, available in up to 80 gigs of GPU memory, is absolutely leading the way in this parallel computing world. This is the AI monster card, or as Tamara likes to call it, the beast itself. This is the beast that we need to feed. And we do so with some very, very helpful advancements in technology. First and foremost, over 2 terabytes a second of bandwidth capacity to get all of this data in and out of the GPU. It's no good to have a super fast GPU if you can't feed it fast enough. Now, we process that data with our next generation, our 3rd generation Tensor Core technology. And more importantly, we also have things like NVLink, those high-speed interconnects between the GPU, so we can readily share this data or grow larger and larger data sets and process them across multiple GPUs with technologies like NVLink. We'll go into details a little bit later on some other technologies, things like GPU Direct and the ability to integrate directly with the storage. But from a foundational level, the A100 is the new building block of supercomputing. It is the foundation of almost all of the future technologies that we're going to talk about. Now, the A100 itself is available in multiple form factors. And we do this so that way you can pick and choose the right sizing that makes sense for you and your application. In fact, we start at a single card in a mainstream server, the existing OEMs that you might already know and love, or deployed out in the edge to handle a lot of that, say, camera data coming in situ before sending it to the data center. Of course, we grow larger from there with our HGX platform, multiple GPUs sitting on a single baseboard in a 4 and an 8-way configuration to train those biggest and most complicated models to handle the greatest AI workloads. And these things are fully interconnected. They have high-speed bandwidth between them all. They have great links with, say, Mellanox or NVIDIA networking over to IBM storage. They are the option when you want to scale up. But that's not our only option. We can actually scale down as well. We can go smaller. And the A100 introduces a new technology that we called multi-instance GPU, or MIG. And what this does, it allows us to carve one of these beasts, one of these A100 GPUs, into 7 individual slices. These slices are hardware isolated, which means there's security and isolation between each of these 7 pieces. Why would you want to use this? Again, it's right sizing. It gives us the ability to run multiple smaller workloads on one invested GPU. You buy one of these and run multiple inferencing jobs, or give it to multiple data scientists to do their life's work on. And because they're hardware isolated, there's guaranteed quality of service between them. The A100 is flexible. As I mentioned before, you can scale it up with multiple GPUs, or you can scale it smaller with using technologies like MIG. Wildly, wildly useful when deploying the same infrastructure and utilizing it in the way that makes most sense for you and your use case. Now, NVIDIA is not just a hardware company. I want to touch on the other side of the house as well, and that is our software. You might hear the terms NGC quite a bit. This is the NVIDIA GPU Cloud, or what we call now the NGC catalog. Now, what we find inside this catalog is a lot of accelerated libraries, a lot of tools, a lot of pre-trained models, software that you need to make a successful deployment of AI in your environment. This isn't GPU computing in the cloud. No, we save that for others. This is NVIDIA's offerings in the software world to help you on this journey. Now, some examples. You can find all sorts of accelerated libraries for whatever your use case. Simulation, for example. Or maybe you want to have your favorite PyTorch or TensorFlow artificial intelligence frameworks, or you want to do some visualization of data. You've got some great processed inputs and you want to make some very good analysis of that with a visualization tool. All of these are available in NGC, and all of these provided by NVIDIA are free. Little known fact, but NVIDIA actually has more software developers these days than hardware developers. And because of the software that we provide in NGC, it adds great value to our accelerators, wherever they are. So for example, that A100 we spoke about before, whether you're running this in the edge or even if you decide to be hybrid in the cloud, all of these tools work everywhere. They even run on your simple NVIDIA powered laptop. So you can get started building your tools on a laptop, and these same NGC containers, these same tools will run in the largest data center or on the smallest laptop. So very, very helpful in your journey on the AI adoption. Now, let me give you a quick example of this software, because I mentioned a lot of different things, and I want everybody to be clear on what these tools are for and why they're important to you. So this is our typical workflow. You want to create an AI workload. You want to add this to your business. You generally start on the left here with things like the frameworks necessary. And again, these are accelerated and available to you for free in NGC. A lot of these are based on open source that NVIDIA regularly contributes to. And some of them we just provide gratis. For example, pre-trained models. So start on the left, pick your application. Let's say we want to do a recommender system or identification. Next, we move into the training. Now, some interesting things. We offer what we call the Transfer Learning Toolkit, which allows you to take one of our free pre-trained models. Let's say I want to identify cars, and we have a model that does that. It picks out cars. And I want to retrain it with just my domain-specific knowledge. I want to look for trucks, specifically red trucks or fire trucks. In that case, we use the Transfer Learning Toolkit to just train it with my business-sensitive data, in that case, pictures of fire trucks. Not only do I want cars, but I only want you to focus on the trucks. Once we have a completed model, we send it over to TensorRT to prepare it for inference. Now, inferencing is, for those of you who are rather new to this, is the act of using this AI workflow, using the finished product here to make decisions. So for example, taking a camera feed in and looking for fire trucks in them. TensorRT prepares and optimizes this framework and gets it ready for actually running at scale. And that on the right is what we use the Triton inference server for. Triton is another free tool. It actually runs on GPUs, on CPUs, on every platform that's out there, on containerized environments, and it runs these inferencing workloads. Now, if you're using things like multi-instance GPU that we spoke about before, Triton can scale across those different slices. It will automatically deliver the necessary AI capacity to your jobs. So how many customers do I need to serve? How many cameras do I need to analyze? Whatever it may be. Again, Triton is freely available. In fact, all of these tools come from NGC, and they're there for the using, whether or not you're GPU accelerated or not. We hope you are, but in this case, we give back to the open source community, or we provide products inside of NGC for you to freely use. And this becomes our full end-to-end software stack. Now, if we bring it all together, what's the total platform look like? We started with those GPUs inside of our high-speed servers, high-speed networking with, say, Mellanox switching, and then we build it on top of the libraries that we already know and love, things like CUDA. We use those AI models at the top-end layer that have come from NGC, put all of this stuff together. This entire data center becomes an AI supercomputer. NVIDIA can provide that AI workhorse. It can provide that beast, if you will. Now, we've kind of touched on the NVIDIA solutions a little bit, but I want to give some examples, some real-world applications that a lot of our customers have already seen. Some of these might be close to home for you, and others, maybe floating out in space somewhere. But I want to talk about a few of my favorites. So where have we seen the greatest advancement in AI, and how is it bettering humanity? Of course, the biggest one is human speech. So things like the OpenAI initiative, using accelerated computing on, say, an NVIDIA DGX, have been able to greatly increase how fluent a chatbot would be with you, or how I can understand what I'm talking about. Now, this type of research is open to everybody. Right? OpenAI provides this, as an open source offering. But these type of advancements are found everywhere. Talking to Siri, talking to your cell phone, having a frontline chatbot. This is universally adopted across the board here. A couple others that I really, really like. On the financial sector side, companies like American Express have been using AI, again, to solve that data problem. Having so many transactions come in on, say, credit cards or any other type of transaction, they are looking for anomalies, things that they would consider fraudulent transactions or types of cybercrime coming in, and they're using this to great success. There's no way a human can look at every transaction that's ever made. Impossible. But AI, these systems that they're building, scan all of these payments in real time, and they identify things that don't fall within the pattern, things that they think are fraudulent. And they do this in practically real time, milliseconds of delay. It's a better world if everybody has less fraud and less credit card losses and less crime. And that's how we're doing it with these. On the other side of the house, still within financial sector, one of the most important parts of that AI journey is getting the tools that your data scientists need to process this huge amount of data coming in. It's great that you have tons of data to work with, but getting it into a format that can be utilized in an AI framework or getting it into an accelerated computing environment requires a lot of time and energy from these data scientists. Now, products like Rapids and used with Dask, for example, Rapids is an AI framework, again, built on open source, but accelerated by Nvidia, that allows these developers, these AI developers, your best and brightest, to get this data in a format in a very easy manner with GPU acceleration, cutting down their wait times immensely. So to get the best business value, as Tamara said, keep those GPUs at full utilization, give your data scientists those tools. Again, Rapids is part of NGC. It's available and it's free in there. Now, continuing on the trend in the financial industry here, RBC is actually building out their own private AI cloud. This started back in 2017. They've got a significant runway on this already. And they're building their own AI, center for excellence, if you will, their own dedicated private cloud, because they knew that this type of computing would be necessary. It would be the future. And they would use it to run simulations or identify risk points or generate business value much, much, much faster than what they could do on a traditional compute cluster. These type of AI workloads, the smart applications that they're building are now at the center of their business. So it's not just a specific application, it's accelerating on a more broad and global scale within all of these organizations, not just one use case, but just about all use cases that have large amounts of data that you can draw inference from. A couple others that I really like to talk about. This is in the materials manufacturing space. Little known fact, but the blue phosphorant components of the OLED screens that Samsung created were actually developed using AI algorithms. Traditionally, when a manufacturer goes to build these type of new conductor materials or new components or new fluorescents for LED screens, they have to make a best guess, and then they have to prototype it. And sometimes this takes a long time to actually build the physical version of this prototype and then test it. With AI, we simulated all of that. And in Samsung's case, when they came out with this blue phosphorant for the OLED screens, this was 52 times faster for them to simulate it first and then to prototype it after the simulation came back. This type of materials design is going to revolutionize manufacturing as a whole. And it's not just manufacturing that they're going to do this with. We were talking about healthcare advances a little bit earlier. Think of the possibilities for drug discovery or not just materials innovation, but any type of innovation in the physical design world. Absolutely revolutionary. Some of my favorites, of course, self-driving vehicles. So for example, Too Simple is creating delivery trucks that no longer need a human driver. They don't have to follow the rules that are put in place on those humans. How many hours a day can they work? The mandatory breaks. By simplifying things like putting AI in command of a self-driving truck or a logistics system, we can actually improve efficiencies. We can maybe have a driver, for now, sit inside the cab of the truck and watch to make sure things are safe. But the ultimate goal here is using AI to create a full self-driving logistics network. It's much safer, it's much more efficient, it doesn't have the overhead that would be used for, say, having human drivers on staff here. I mean, all around, it's a fantastic, fantastic opportunity. You always see these type of examples anyway, things like Tesla with their self-driving technology. But it's not just the simple commuter car. We're going to change every type of logistics, whether it's the planning done by USPS, our very own postal service here in the States, to track those packages and then load them onto these autonomous vehicles. Again, operational efficiencies at its best. A little bit closer to home, still talking about transportation, but we're also using AI to improve our quality of life, our traffic flow systems. So nobody likes to sit in traffic, of course. And AI in this case is integrated with smart city cameras. We are watching the cameras, the traffic flows, building patterns, and then using that knowledge to create a nice, efficient pattern with those traffic lights. Improve congestion. Rather than just using a timing or a simple sensor, actually look at the flow patterns as the whole city and adapting those traffic lights to allow this traffic to go quicker. I'm all for this personally. I can't wait until the world is fully remote. But until then, and when we do have to start commuting again, I will happily have an AI city manage and determine when my traffic lights change for the least amount of commuting time possible. Now, this type of solution, this actually runs at the edge. This is on a Jetson platform. Jetson comes in a small 5-watt package, all the way up to so like full automotive package. But these are edge deployments using that same technology, same software from NGC, same frameworks. Everything else is the same. You just choose where to deploy it. And in this case, it's a tiny little device, probably in the traffic camera stack, out at the edge to make decisions based on the information it sees. Absolutely amazing. Okay, I briefly touched on this before, but cyber defense, cyber security. One of the biggest problems, as I mentioned earlier in this presentation, is data, the pure quantity of data that could be an attack vector. You can't watch every network packet. You can't inspect every single email that goes in and out. You just can't. You need to have systems in place to do that. And what better system than an AI-powered one to be able to analyze that massive amount of data that's constantly moving around and then make security decisions based on that. Shut off an infected machine or shut down a cybersecurity attack or a ransomware encryption as it's in progress. That's the real benefit here of having AI in the cyber defense or in the cybersecurity world. And this is already in place by companies like Accenture. They are using this type of technology already to analyze a bunch of data, millions and millions of security alerts a day, so they can figure out if it's a pattern, if it's a global attack, if it's a distributed attack, DDoS, whatever it may be. This is the future of security here. Now, one more. I love this one. As Tamara mentioned, my background is in cosmology and astronomy, so we can use AI to save the planet. Right? Let's go all the way up into space. The NASA Frontier Development Lab actually did this experiment. They used AI to successfully classify which type of defense mechanism would best save our planet. What better use of AI than actually saving our own planet? In this case, we're trying to deflect asteroids coming at us, and we've got several options available to us. But AI is going to be our best chance to potentially save the planet or defend us from a future asteroid strike if, should we ever come to that. But I love this. This is a great application of AI in a way that you don't normally think of. It's a very novel use of it. But that's just the point. We can do this across every industry with any type of data. It's going to be revolutionary. And Nvidia, with our partners like IBM and R2I, are going to be leading the charge. We're going to be deploying these systems. And these partnerships are what's going to drive business value to you and your customers and your business partners and everybody else within the industry. So with that, that's the end of my part. Hopefully that was informative for everybody.
Can I ask one question, Dan? But just before Douglas starts, I know it's another well-kept secret that Nvidia bought Mellanox. Do you want to just quickly say why they bought Mellanox?
Yeah, great question. So when we started building these large deployments, these supercomputers, if you will, one of the things that we noticed is that the amount of data that we need to feed into these systems, we just didn't have high enough network capacity to feed this quick enough. So by integrating Mellanox technology, specifically things like InfiniBand, as we scale these GPUs larger and larger to handle these 500 million or billion or almost trillion parameter models, having that network components so that way we could distribute the workload across a pod or a super pod or a giant network of GPUs wherever they may be, even if they happen to be in the cloud, was critical. And there was no two ways around this. If you can't feed the data fast enough, if you can't let the GPUs talk to each other in an efficient manner, then you just can't scale. You can't tackle these big problems. That was one of the biggest driving factors behind Nvidia acquiring Mellanox, because their technology fits so well next to the GPU. Putting their DPUs or ConnectX network cards right next to and attached to the GPU is the way that we get data in and out. Not just GPU to GPU, but as Douglas is going to explain, getting data from storage in as well. We got to feed the beast, and networking is the core component there.
Perfect. Thanks.
And so thinking about this in terms of your organization, these are the requirements: hybrid cloud, enterprise data services, secure access, and multiple workloads at extreme scale. This ability to have all this data is one thing, but that second set of bullets that Tamara introduced up front, which was that 80% of the time is spent on data preparation. And if you don't have an organized data science approach that includes your data, your storage, and in the world you come together, rather than having iterative 80% of your time, you can now have projects that use the same data and reduce the amount of time it takes for the data prep. So multiple projects, multiple adoptions, this infusing of AI into an organization requires shared data access. So this is not just your IT, hey, am I going to pick the fastest storage? This starts to be, do your data scientists know how to use the data that they have, so you don't spend all this time working on data preparation always. So Tamara also teed up that when you think of storage as kind of a set of boxes, we really want you to also think about this as the software that goes there. Dan hit upon the advantages of NGC, the modules, how much work inside of NVIDIA is software dependent today. The huge amount is also true for IBM storage. What we really do is write software and then optimize that into solutions. And by using Spectrum Scale, which is a global file space that you can use with any sort of protocols very, very fast, with the ability to be on multiple sites and multiple connectivities through something we talk about as being a single global namespace, really does change the way it works. Now, software is one thing, and ultimately we do have to deploy this in a hardware platform, and we want this to be storage made simple. And so what that really means is these are packaged in what we call our enterprise storage server solutions. The ESS 5000 scales out for capacity. The 3200 is our flagship for AI. That gives you 80 gigabytes a second of throughput for low latency network access, and is fully enabled with tech preview for GDS today. So that means eliminating the bottlenecks in the client. And we're seeing throughput numbers that are incredible to a single DGX or to small clusters of DGXs, and starting to test GDS on very large clusters as well as we go forward. And you need to organize all this with a single piece of software as well with Spectrum Discover. Yeah,
Douglas,
Tamara?
can you just push the hide, because we see the R2I sharing on your screen?
Oh, there we
Oh, now it hit everything. There. Perfect. And
There we
GDS
go.
is the GPU Direct that we were talking about, right?
Exactly. GPU direct storage, often shorthanded as GDS. And we'll talk a little bit about where that really kicks in and why people should be adopting it. And it's something that developers take advantage of that really is also needs to be enabled in your storage. So I'm going to quickly walk through a few quick points here. You need to collect this data and have that all in one place. You also have to worry about how to organize it. And metadata is the way to do this, because organizing that data, knowing where it is, PII, personally identifiable information, getting rid of adhering to GDPR and things of that sort becomes really business critical. And you can't have multiple copies running around in different data science teams and still be able to do that. So metadata is what you use to track and make that data visible and understandable. And you need to be able to do this quickly and with speed. And to that end, IBM has a product called IBM Spectrum Discover. This is software that you can implement that is not just IBM storage specific, but works on any piece of storage, pretty much any piece of storage. Any filer works with NetApp, it works with EMC, it works with the cloud. So it also keeps track of your data that might be in AWS, S3, or on Azure or somewhere else. But it's really built with this idea of a single platform and view of where your data is and your metadata. So talk to people about how to organize in that way. So then we talk about having metadata to organize it. You've collected the data and you can span from place to place. Now we get into where Dan was talking about specifically, training, inference, being able to infuse this everywhere, and this idea that storage performance really does matter. I did key up saying that's not the only thing I want you to think about, but goodness, we are the fastest solutions available out there today with all NVMe 3200 and Advantage with the GPU direct storage. That gives us a performance tier at the top that can sit on top of anything you want it to be. And that includes, for some of our great examples, like Continental, who designs automotive autonomous vehicles, can now tier data down to large capacity stores. We have a high performance automotive ADAS company that is pulling in so much data that they actually tier to tape in order to drive the lowest cost down. But the data scientists have access to that and visibility to it from Spectrum Discover, but access to it for training by promoting that up into those super fast 3200 nodes. So this is another thing about our global namespace, means that data can be automatically tiered and monitored and moved without end users' awareness, without end users having to do things explicitly, and tracked with the same metadata opportunities as Spectrum Discover. We package this together with NVIDIA, offer the NVIDIA DGX systems in reference architectures. And that makes it simple for you to deploy it so that you can have something that really is fast and trained. These DGX systems are, of course, the flagship for NVIDIA, but the same thing is true if you choose to run with a different set of servers from another vendor using the NVIDIA A100 CPUs. You can do a huge amount of training with those as well. You don't get full advantage of the scale up that you have in the DGX, which is pretty unique, but we'll talk about that in other webinars, but it's all available to you and ready to go. So that's it, performance across a data pipeline once you've collected, organized, and it can analyze. So let's talk a little bit about infusing this and then come back to a conversation we can have, Dan, about what else we've done together. When you think about infusing it, you are thinking about organizational, that inference in one place, something that might be trained in the cloud, inference on site, something else. You've got to now keep track of this data. So the call to action for executives is to start thinking about how your storage foundation supports a data operations foundation so that you know and trust and use the data you have across all data pipelines with automatic classification and an enriched and enforced catalog so you can keep track of the data you're using. It's a key component to being able to roll this out into enterprises, secure environments, financial services, etc. You need to be able to follow the regulatory rules and be able to follow the PII, and you need to prove the governance of your data models. And when we talk about the storage that supports that, it is that cost optimization that allows you to accumulate data together, make it easy to manage, simple to grow, meets your enterprise IT requirements and your regulatory requirements like backup, global ingesting, sharing, and to be able to then share to all of your users for an analytics environment that is both AI and big data aware. So that talks me through a quick 10-minute view of the AI ladder and why storage matters, right? You need to collect, organize, analyze, and infuse it all the way through based on a great storage platform. So I'm going to turn the page a little bit here and talk about our work specifically with NVIDIA. You know, one of the things we have is these reference architectures specific for the ESS 3000 and its follow-up, the 3200, with the DGX servers. We also then have red papers and available to talk about how we tier together to create a global namespace for that, for ingesting or going to cloud object storage or to tape. And we provide that easy-to-use Spectrum Discover to manage your
You're breaking up, Douglas.
unstructured
We're
data.
not hearing you well.
The not unfortunate world of where we're at. So the last thing I want to talk about is the collaboration.
You're breaking up quite a bit. We don't hear you at all now.
I'm unfortunately just hardwired into the same environment I've been in, and you know, I hope that my audio is coming back. It's apparently a challenging day today.
Yeah, it's a little better now.
All right. So what I'm going to do very quickly is to take Ingest. I was trying to see if I could hide my video, which isn't providing that for me. So the GPU direct storage does allow us to do allows NVIDIA and a developer to do something unique, which is copy data directly to a GPU. This avoids the PCIe bottlenecks inside the system and the copy through the bounce buffer, through the system buffer. What you really care about is that this increases effective bandwidth, significantly decreases the latency, and reduces the load on the CPU. And what you end up happening is you end up with GPUs and CPUs that run incredibly faster because they're not necessarily sharing the same data paths. And we've seen this in real world data as people are trying to work with low latency environments for pinning large models into memory. Now, we've been doing this with NVIDIA for a long time. That's the latest piece. But some of this really was the age of AI brought on by the first supercomputers that were purpose-built for AI, Oak Ridge's Summit and the Lanol's Sierra. And now we're talking about huge changes in the data pattern and the ability for us to manage all this, to manage the kind of AI workloads that are required. And this is translated into incredible opportunities with things like I mentioned earlier, Continental, ZF, and lots of other enterprise customers where we share IBM storage with NVIDIA, CPUs, GPUs, and DGXs. Dan, I want to bring you back here a little bit to talk about one of the great case studies at Oak Ridge, right? This is AI-generated vegetation maps, where that massive shared cluster that was introduced in 2018 is still on the leading edge in the top 10 of the supercomputers out there, literally with 2.5 terabytes of data throughput against it. This is a chance for us to talk a little bit about how we work together to take in huge quantities of data at Oak Ridge and study and monitor the vegetation dynamics as it goes forward. And this is a chance to actually look at how we can model climate change better, figure out where things work and what humans might be able to do to be able to affect climate change. So in the same way that Dan was talking about saving the world from space debris, here we're trying to save the world a little bit from ourselves by working together and chunking through data that no one ever thought we could chunk through before, with literally tens of thousands of GPUs and multiple terabytes of data throughput in order to support it. Yeah, so, Tamara, I hope my voice has come back a little bit. Yep, Dan, go ahead, please.
I was going to say, I love the use case, because how do you manage the data when the data is literally the entire world coming in through geospatial systems? It's incredible. And then how do you simulate that on a supercomputer with accelerated computing? It's amazing.
And these are the opportunities that we hope to present for our clients, for your clients, no matter what the industry they're in, right? To be able to go through more data and yet make it as efficient as possible, both organizationally and performance-wise. So it's a great partnership we've got going here to be able to deliver this to our clients in a way that's easy and simple to use.
And Douglas,
Tamara,
I heard
I'm going to turn it back up.
Yeah, I heard the sound was really just an issue for me. Other people didn't seem to have an issue, so.
Oh, well, glad to hear so. Thanks so much.
All right,
Hopefully,
so I'll share.
Despite the technology challenges, we have proven that you can accelerate AI workloads from edge to cloud securely and with the services that you need, no matter where you go. So let's see what kind of questions we might still have in the few minutes we have left. I want to make sure I unshare this.
Perfect.
And,
So
move forward.
I'll start sharing. I'll kind of come on. Now my share's not working. Come on. Do you see my screen now?
I do indeed.
All right. So Kim, I'm going to ask you to ask the questions if there's any in the Q&A. And
yes.
I'll just finish up with the next steps. And the next steps is, please go ahead and share the link to this webinar. We've recorded it. So you can, if you found it interesting, please share it with anyone that you know that would be interested in the content. We have 2 more webinars coming up next week. One is going to be making it real and avoiding the pitfalls. It's going to be more on the infrastructure side, more for people that are managing the cluster itself. And then the third one is really going to be one focused for the data scientist and talk about the tools in the trade. So with a different focus, but a lot of the same, talking about Nvidia and IBM. And if you want to have anything personalized, please reach out to us. We could do a personalized session. We could do one specific for use cases and go a little deeper on some of the use cases for your particular industry. We could help you with doing the use case workshops. and we can do service engagements around building the AI roadmap, etc. So you want to do some of the, and the contact information is there. You can either write to myself or you can write to info@R2I.